So we're going to do a quick video explaining how we do conditional offsets and not offsets, conditional branching, weights, and other fun things with some of the instruction commands. We're going to do some multi-branch or not multi-conditional statements and go from there. But what I've already done to make my life easier is I have already created 3 jobs. And if we remember, we just go like this, and I have a circle. And if I want to call each individual job, I can just do call. This is going to be a little bit of review. I'm going to do square, and I'll do instruction and call triangle. And in each one is different motion types. So circle's got the circle type. Square is just the linear, and then triangle, just for fun, I did joint, just to say that there's difference. And if I run this program, I've also created a user frame. But if I run this program, you'll see it kind of go through a circle over here. Now I can do, and it just went really, really fast with my triangle. And there's my triangle right there, and everything's hunky-dory. So there's my jobs. Couple things. If I go on the back end of that, I can have it turn, I can have it set to do some indirect stuff here, but which I'm not going to go into now. Let me go to choice and let me say none. But there's some other things I can do. Again, if I wanted to do if statements, I could edit command, insert a line, one line, and I could add a jump label. So go to jump label. So call it label 1, enter instruction, label jump label to 2, enter, and do that. And then it's going to loop for forever and a day. So going to loop for forever and a day. So there's my square. It's not quite, I'm doing it more from the corners, but yeah, you can see some, and it'll just keep going and going and going and going until I get out of it. There's my circle, but you got the idea. If I hit escape, function abort all. Function abort all. Hit edit again. Let me go select and go to my select job. There's my job. Okay. Now, what if I just want to call, and then I could add, remember, a couple other things. I could add a conditional statement here. This is, again, all review, but I'm just reminding you. I could do an if select and do a register if register 5 equals, then jump label to 1. So, and I could have a adder go in there. So remembering all that stuff. But that's going to go through each different job. Let's talk about, I'm going to keep the jump label in there. Let me just hit undo. There, and I'm going to go back and put the jump label back in, just a straight old jump label. What happens, though, if I only want to call each job when I have specific conditions? So say I want job 1 to be called, the circle job when register is equal to 1, job 2 to be called when register is equal to 2, job 3 to be called if it's equal to 3, and so on and so forth. That's when I would use, in the if select, the select function. And if I want a function, I can go to register 5, and when that equals a constant of 1, then I can call program circle. Or let's do the square. The next line, if I want this to be the case, I can go if select again, and then I can do, again, the same. It's going to be the same constant, because it's going to say, so select R, and if constant equals to 2, then I can call program triangle, and then do it again, instruction, if select if equals to 3, whoops, let me go to choice, 3, call circle. All right, then the last line, if I do if select, the last one, select else, jump label back to 1. And I'm going to do a split screen just to demonstrate on this. I'm going to pull up my data. And right now, register 5 is equal to 0. So now if I run this job, function abort all, you can see it's running, but it's just skipping over everything. I'm going to let go. If I go to 5 and put a 2 in there, say that's information I got from my DCS or well, not DCS, that's my data acquisitions or HMI or PLC. Now if I run this, look, it's going to do the triangle. Now if I run it again, it's going to do it again. Now if I go back in here and make this a 3, hit forward, hit forward, you can see it's my circle. If I hit it again, circle. Now if I wanted this just to be the 1, you can see that I can go between the different jobs. And there is my bad attempt of a square. But it's just a matter, now it's being called based upon the... So if I had a bunch of jobs that I wanted to choose between, this is how it would do it. It makes it a lot easier, and I just have to look at one register. So that's nice. The other things that we can do is we can do multi-statements for if statements. So let me, or wait commands if we want to hold up on wait. So I'm going to go through and just delete all this. Okay, and let me go back to Shift and Display. And we'll just do a single display right now. I can do also wait commands we've looked at. And we've done this, and I've recommended this before. If I just put a wait and how many seconds in there, this is really good. If I'm using a gripper, if I'm moving high speed, it moves too fast sometimes to really grip, so I have to put in like little slows to slow it down. So close and then pull up, just so I'm not just like crashing into things. Wait can slow down your processing time, but waits can also be a way of stopping the program if need be. So, like, if I have a certain point when I want to make sure a part's there, for instance, I can go in here. Oh, what's going on? I was holding down Shift. That's what it was. I can go in here and go down to this bottom line here with where it's got the parentheses. And notice it says mix logic. I can actually, so say I got DI1, enter. I can insert an equal sign and on. And what I can do is also put an and in there. And say I want to make sure so say I want to make sure a part's present and I want to make sure the gripper's open. I want to wait, make sure there's a part, if there's a part there, and if the process beforehand is doing something. So say, not DI, let me do choice. And say there's another DO that's reading. Whoops. Choice, delete. Let me go back to insert. Next page. Next page equal and say off. So say there's a part there and that the next process is off, meaning that it could be something in transit. I could have the job not go on. So if I hit this and forward, you'll notice it's busy running. If I go into my I/O and input, and let's do sim and turn this on, then go to edit, watch what happens. Instead of running, once I go through it, it's just skipped it right on. Let's demonstrate this with motion. So let me insert a job. Call circle. Instruction wait. And we'll mix it up. So say register 5 is equal or less than or equal to, let's say 4. Whoops, that's indirect. So let's go direct. Choice, let's make that. Oh, I hate it when I do this. There we go. When this is less than, weight is less than or equal to 5. Or DI1 I think I can just do DI, no I can't. DI1 equals on. Okay. What that does is now say, oh wait, if either of those conditions are true. Call program, no, not circle, let's do square. Okay, so if I run this job, forward, run through it, oh, variable mismatch, oh that's right. Shoot, I always keep hitting the wrong thing because I see the equal sign and I freak out. Sorry, my robo guy just crashed on me. But now I just want to go in and show you because like with the and needs both conditions to be met in order for things to pass through. So right now, just to show you, my IO digital 1 is off. Data, this is greater than 6. So both are untrue. So if I run this job, it stops right there because both are untrue. This is what makes wait commands so much fun, is that it's almost an inverse thought, because right now it's off and it's greater than 5. So it's waiting because it's not this is the conditions that will allow it to pass. So if I go back into IO and simulate this to on, so and I go hit edit and try to go past this, it's still waiting because both have to be true. But if I go in and say, and just make this easy, let's make it less than or equal to 10. Now, if I run this job, it passes through. And that's with the ands. Well, let's take a look at OR. If I change this to an OR, okay? And by the way, I can go out here to choice and I can do a timeout, so that if something, I can put in a timeout, meaning if it goes super long, I can put a label down here. To jump the job or jump over that. So right now this is OR, meaning this or this can be true in order for this to go. So just for kicks, I'm going to change this to, let me change that back to 5, and I'm going to change this to off because right now it's on. So if I hit forward, I go through my circle. Now it pauses. But once I change this to on, it's going to go through. Because either one, if it's true, will allow it to pass. You see I'm going to square. Okay? So it doesn't, so the conditions here is basically what's the combination to allow it to pass. Usually, if we put a time in, it goes through that time, so it's kind of like a speed bump. But again, that's what gets confusing about waits. What it says, wait until these conditions are true. So either this is less than 5, or this is on, and in this case, it's on. So, but if I change this to off and keep this the same and just hit shift forward, you'll see it waits. Now, if I change this to 10. It goes on. Okay? So waits can be confusing, but this timeout is great because, so if I put this back at 0, let me say less than or equal to 0, and just sit here, the timeout will say eventually when it will just run out of time, it's eventually just a jump label, kind of as a, okay, nothing, jump out for it. I won't hold it that long because I think the timeout conditions needs to be set up in the variables. I have to look into that, but that timeout will say if it's going too long, and you can see it's already cut out, so it's no longer green, so it went back to the job. You could have timed that, but that was a timeout. I think maybe 60 seconds, maybe. But those are, so that's what we did. Select, we did different waits, and now keep in mind, like I do the parenthesis one. Only because that gets some really fun logic. So for instance, when I do a gripper sometimes with DO or RO, for instance, if I want to just change a state to an opposite state, I can go this. Oh, down here. Where's my robot IO? Robot IO, where are you? Robot IO, there it is, all the way. What this is saying, make this the opposite state of this. This is a way of inverting states. So I like using the parenthesis for that reason. This might be enough. But so that might be enough to say when it's not DI1, 2, that's another thing. We can give it a try here. So not DI1, if I go, so because that's saying, hey, DI1 is on when DI1 is off, this is the OR statement. So if I go back in here to this and turn this off, now I should be able to advance. See? So that's another way of writing things. It's just whatever floats your boat, because all the stuff I did too here, function board all, select, enter, all this other stuff could have been set up to under wait and on here, and you could still do the ands. I just did the wait down, so if I wanted to, I could have done instruction wait R5 R2 equals the constant of 3. I could put in an and or a timeout, so I could do this all here at the same time too, but I get limited. I might be able to combine more the other way. So just keep that in mind. There's many different ways to skin that to do that. So command delete. The last thing I will point out, just because it's short, is payload. If I wanted to put in a payload, so for instance, if I go to system and motion, I can set up different payload capacities and then run different schedules. So this is 3 kilos. I could set this to be So if I have automatic tool changer and want to change payload, hit detail, I can go in and call it something like, payload schedule, like hose. Sorry. Enter, option, keyboard. My favorite, I could change this to 5 kilograms. And I could talk about where the center is too, based upon, so if there's an off center. Overload, whatever, 5 kilo. Let me do 1 kilo. Yes. And then I could off center it too. So say it's because this will help change the kinematics and the motion type, because the more accurate of a payload you got, the better. And you can do some payload inertia types too, getting in that physics. So if I wanted to if I go back to my job, if I wanted to, so if I want to put in edit command insert, I could say for this first job, instruction, payload, make this payload number 1. And then down here before this one, edit command instruction, or insert, sorry. I could say before this job, I could say do payload command number 2, for instance. Pretty simple, but it can be, this is where, it can get complex. So if I run this, if I go back to menu, setup and motion, system, motion, you can see that the, back out, you can see the active payload number is 2 because it got changed in that job. So pretty straightforward, some fun things you can do with some extra motion stuff, and that should cover a lot of this week's lab. So yeah, have fun.